Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq bin Azhari. So today I will present about the calculation for question 2 and question 12. So we will start with the question 2 and we'll look at the question first. The question 2 is determine the definite equivalent circuit at the terminal A, B for the circuit shown below. So in this circuit, there is a independent source and one dependent source. So if there is a one dependent source in the circuit, we cannot find the RTH directly. So we need to find the VTH and I short circuit. So the VTH will obtain here and I short circuit will obtain at loop here. So next we will look at the calculation. So the calculation, we put the V1, we put the node at here and here. So we name it as V1 and V2. And so the V2 is equal to VTH as the voltage here is equal to voltage through the terminal. And then the Ix is equal to V1 minus V2 over 4. So first we will do the KCL at V1. So there is a negative 2 ampere plus with V1 minus 0 actually over 2 plus with V1 minus V2 over 4 is equal to 0. So we move the negative 2 to the right side and we will get V1 over 2 plus V1 minus V2 over 4 equal to 2, and we name it as equation 1. Then we do the KCL at V2, which is Ix equal to 1.5 Ix. So we know the equation for Ix is V1 minus V2 over 4. So we insert the V1 over we insert the V1 minus V2 over 4 into the equation. So we will get V1 minus V2 over 4 equal to 1.5 times with V1 minus V2 over 4. And then 1 over 4 we multiply with V1 minus V2, and 1.5 over 4 we'll multiply with V1 minus V2. And then we expand the equation. We put the V1 on the left side and V2 on the right side, and we will get negative 0.125 for V1 equal to negative 0.125 V2. And then we will get V1 equal to V2, and we name it as equation 2. So next we insert the equation 2 into equation 1. So we take V2 and insert it into equation 1. So we will get V2 over 2 plus V2 minus V2 over 4 equal to 2. So V2 minus V2 is equal to 0. Over 4 we will get 0. So V2 over V2 over 2 plus 0 equal to 2. So we move the 1 over 2 to the right side, and we will get V2 equal to 2 times 2. So V2 we will get 4 volt and VTH we get 4 volt. So next we calculate for I short circuit. So first we need to do at the KCL at node V2 at here. So the KCL is Ix plus 1.5 Ix equal to I short circuit. So we name it here as loop I1, and here loop Ix, and here is loop I short circuit. So next we do the KVL at Ix, where I1 is 2 ampere. So at here we know the I1 is equal to 2 ampere since there is a independent source. So we do the KVL and we will get 2 times with Ix minus I1 plus 4Ix equal to 0. So we expand the equation, and then we insert the value of I1, and we'll get 6Ix equal to 4. And then we move the 6 to the right side, and we'll get Ix equal to 0.67 ampere. And then we get the value of Ix. We insert it into equation 3. So from the equation 3, we get the I short circuit equal to Ix plus 1.5 Ix which is we'll get I short circuit equal to 2.5 Ix, and we insert the value of Ix in the equation, we'll get I short circuit is 1.675 ampere. And then we have the value of I short circuit and VTH. We then can calculate the value for RTH. So the equation for RTH is RTH equal to VTH over I short circuit. So we insert the value of VTH and I short circuit into the equation. We'll get the value of RTH is 2.388 ohm. So next I will discuss about question 12. So first we will look at the question first. So the question is, for the circuit shown in figure Q12, find all unknown node voltage using nodal analysis. So the main idea here, we need to find the voltage in this node VA and node VB and node VC. Okay, next. So we will look at the calculation. So here we put the node VA at here and node VC at here because there is no component in this wire and this wire, so it is the same node. And then at here we know the node VB is equal to 12 because there is a voltage source here, and Ix here is VC minus 0 over 3 ohm. So the Ix is equal to Vc over 3. So first we will do the KCL at node VA at here and here. So the KCL at node VA is 2Ix plus VA minus 0 over 4 and VA minus VC over 2 plus with VA minus VB over 12 and equal to 0. Then we insert the value of Ix, and so there is a 2 times with VC over 3 plus VA over 4 plus VA minus VC over 2 plus VA minus VB over 12 equal to 0. And then we make the denominator is the same value. So the 2VC over 3 times with 4 plus VA over V4 times with 3 plus VA minus VC over 2 times with 6, and then we'll get 8VC plus 3VA plus 6VA minus 6VC plus VA minus VB over 12. So 12, we move it to the right side and we'll get 0 as well. And then we look at the KCL at node VC at here. So there is a negative 1 plus with VC minus VA over 2 and VC minus 0 over 3 and plus with VC minus VB over 6. So we do the same thing as before. We make the value of the denominator same, and then we get 3VC minus 3VA plus 2VC plus VC minus VB over 6. So the negative 1 here, we move it to the right side. And then we move the 6 to the right side and we'll get negative 3VA minus VB plus 6VC equal to 6. So the 10VA minus VB plus 2VC equal to 0, we set it as the first equation. And then the 3VA minus VB plus 6VC equal to 6, we put it as equation 2. Then we insert, since the VB has value, so we insert the VB into both of the equation. So we insert the VB into equation 1 first. So 10VA minus 12 plus 2VC equal to 0, and we will get 10VA plus 2VC equal to 12. And we set it as equation 3, and then we insert the VB into equation 2, and we'll get negative 3 VA minus 12 plus 6 VC equal to 6, and we move the negative 12 to the right side, and we'll get negative 3 VA plus 6 VC equal to 6 plus 12, and then we keep the VC on the left side. We keep the VC alone, so the value is the equation is VC equal to 18 plus 3 VA over 6, and then we set it as the fourth equation, and then we insert the fourth equation into third equation. So we'll get 10 VA plus 2 in bracket 18 plus 3 VA over 6 equal to 12. And then we'll get 10 VA plus 6 plus VA equal to 12. So the 6 we move to the right side, and then we'll get 10 VA plus VA equal to 12 minus 6. And then we calculate the value, and we'll get VA equal to 0.545 volt. We insert the value of VA into equation 4, and we'll get VC equal to 18 plus 3 times with 0.545, which is the value of VA, over 6, and we'll get 3.273 volt. So now we have the value of VC, and we can find the value of IX. So the IX is IX equal to VC over 3. So here IX equal to 3.273 volt over 3 ohm. So the IX will get 1.091 ampere. Therefore, we will get the value of VA is 0.545 volt, VB is 12 volt, VC is 3.273 volt, and IX is 1.091 ampere. That's all for my calculation for question 2 and question 12. Thank you for watching.